I'm Harold Vermis. I'm very pleased to have an opportunity to make just a brief mention of Jerry Coyne and he's a distinguished emeritus professor of genetics at the University of Chicago, who is known throughout the scientific community as being one of the most enlightened geneticists who brings the case for evolution to the public. And all of us who do biology, as I do, live in the penumbra of the statement by geneticists in the early part of the century that nothing is explainable in biology except in the light of evolution. I've been a virologist and a cancer biologist, and if you want to understand how viruses behave and how they change, even President George W. Bush showed some evidence of understanding of evolution when he tried to describe the influenza epidemic late in his second term, because he understood that viruses were competing with each other for vibrant growth. Jerry's going to tell us a lot about how evolution works, and more importantly, for some aspects of the problem, why large numbers of people in the United States and not so much in other advanced economies don't believe that evolution occurred in the way that Darwin described and many others have validated in many ways. So without further ado, Jerry's going to take the podium. He's going to talk for about 35 minutes. We're going to save, hopefully, at least 10 minutes for questions from the audience and responses by him. Jerry?
Thanks, Harold. I'll talk. Thank you. I'll talk as fast as I can because there's a lot of evidence for evolution. When Harold mentioned Bush, I just realized that I've never heard Donald Trump say anything about evolution one way or the other, whether he accepts it or not. So some reporter should ask him that question. Anyway, let me start by asking you a question. How many of you accept evolution as true? That's what I figured, 100%. This is a good liberal crowd. How many of you accept evolution because you trust the authorities that tell you it's true, as opposed to actually, how many of you actually know the evidence for why evolution is true? Raise your hand there. Okay, so we have about 30%. How many of you think you could debate a creationist and do a reasonable job? Okay. Well, I bet you couldn't, because creationists are wily and they spend their lives doing this. So what I'm going to do today is at least give you the ammunition to get to stage 2. That is, you will understand why evolution is true and why scientists believe it is. However, realize that most Americans don't believe evolution, don't accept or reject evolution based on the facts that I'm about to tell you. Here's a statement from Steve Picker's latest book, which is basically true based on studies that professing belief in evolution has nothing to do with knowing the facts about it. It's a sign of tribalism, ideological, political, and religious tribalism. In fact, whether or not you accept evolution correlates with no other index of scientific literacy. So it's a statement about your religious beliefs, your political affiliation, etc. And so we'll talk a bit about that at the end. Nevertheless, I am going to give you the facts, because at least there are some people whose minds can be changed with the facts. Yours already have been, but you're going to meet a lot of people who haven't been. Okay, why is it important that we understand evolution? Well, there's a number of reasons. First of all, I consider it the supreme intellectual achievement of humanity. It is this peculiar recursion where this thing in our skull has been able to figure out how this thing in our skull got there. And this is unique amongst all animals, that we alone can figure out how we came to be. Second of all, it's the ultimate ancestry, if you're into family trees, not just of us, but of every single living species. And so it ties us to everything that's ever lived and is living now. It involves comparing explanations, which is the way I teach my class. You have creationism, the biggest going opponent of evolution on one side, evolution on the other. How do you adjudicate these competing paradigms? Well, you use facts, or you're supposed to use facts. And so it's a model system of the way science actually works. And it's a good way to demonstrate that in the classroom. It is a paradigm of using naturalism, as Sean talked about in his talk the other day. We can understand the physics of everyday life using complete naturalistic explanations with no site of supernaturalism at all. And that's also true for evolution. There's no need to invoke anything besides natural laws. The evidence for evolution, which is going to form the bulk of my talk, is diverse and amazing. So I hope to at least astound you or maybe amuse you with some cute little pictures. It has important effects on our self-image. You're going to think differently about yourself if you think that you evolved rather than you're a special product of a creator and you're an exceptional creature amongst all the creatures on this planet. And as Harold said, it's a vital part of any biological explanation. And in these trying days, studying evolution gives you a respect for evidence. Okay, this is true news, not fake news. Okay, so you can accept or reject evolution based on the evidence. I'll start with the bad news, which is how deeply Americans refuse to accept a theory which is extremely well buttressed. This is a Gallup poll which has been asked every year since 1982. They ask Americans, which of the following do you believe how human beings came to be? They evolved from earlier species. That's straight naturalistic evolution. Or they were created by God in the last 10,000 years. That's biblical creationism from Genesis 1 and 2. And humans evolved, but that evolution was guided by God. That's what we call theistic evolution, that a divine being poked his, her, or its hand into the evolutionary process at certain points to create certain desired characteristics. And one of those characteristics is Homo sapiens, which is ultimately where God is supposed to poke his hand in. So here's the data on, and this is from just last year on the Gallup poll, and you can see that 30%. Is this thing working? Yeah, okay. Does it not work here? Oh, okay, well, I'll just give up with that. 38% of Americans think are young Earth creationists. That's nearly 4 in 10. An equal number, 38% of them are theistic evolutionists who think God poked his, her, its hand in, which means a total of 76%, or 3 out of 4 Americans, do not accept evolution as a purely naturalistic process. Okay, and then 5% of them are ditherers, and you can do the subtraction from 100%. Only 19%, or 1 in 5 Americans, accepts evolution the way that I teach it in my classroom, the way every biologist teaches it in their classroom. So that's a pretty dire statistic. That means when you walk down the street, not necessarily of Kent, but of many American cities, 4 out of the 5 people you pass are going to reject evolutionary biology. And that acceptance has held steady for 34 years. Oops, sorry. This is the Gallup poll over 34 years. Is this thing not working on the screen?
I think it just...
Well, what can I do? Okay, you can see it's on the top line are creationists, biblical creationists. It's remained pretty steady at about 40% since 1982. Middle line, theistic evolutionists, again, pretty steady, so things aren't improving. Remember, this is the age of Richard Dawkins, of Stephen Jay Gould, of Carl Sagan, of all the great promulgators, David Attenborough, of evolutionary biology. You'd think that all this effort would have increased the acceptance of evolution. It has done nothing, although we do see this heartening uptick here in naturalistic evolutionists. It's gone up all of 10%, from 9% to 19% in the last 34 years. So there's some evidence for hope here, but at this rate, it's going to be another 2 centuries before this country accepts evolution the way other countries do. Here's the way other countries do. This is a list of 34 first world countries. I don't know if you could read that. Maybe you want to move down front if you can't. Ranging from Iceland, Denmark, Sweden at the top. It's funny it works there, but it doesn't work there. To Turkey and some other countries at the bottom. And the acceptance of evolution is the length of the blue bar. Those that reject evolution are the length of the red bar. And the ditherers are the yellow bar, the so-called agnostics. And you can see that Iceland, Denmark, Sweden, France, Japan are at the top. They all accept evolution about 80%. That's where the United States is. We're next to last amongst all, yes?
Why is there no Middle East or?
Yeah, hold the question to the end. That's a good question. I'll tell you in a second. There's no Middle East because you're not allowed to ask in the Middle East. If you went to Yemen and said, do you believe in evolution? You know, so, I mean, that's true. So we're next to last, right above Turkey. which is really sort of an embarrassing position to be in. I mean, Turkey rejects evolution because it's largely a Muslim country, and the Quran explicitly tells you it has its own Genesis story, but the Quran is taken literally. So this is an embarrassment. Why is this? Largely because, as Harold hinted at, it's religion. We also happen to be the most religious first world country in the of all those countries, and that's why people reject evolution, because rejection of evolution is always predicated on a religious background. I've only met one creationist in my life who hasn't been a religious person, and I think that guy was lying. Here's a graph I've plotted of 32 European countries with putting their belief in God on the x-axis with their acceptance of Darwin on the y-axis. And you can see there's a negative correlation. It's right there. It's highly statistically significant if you know statistics. The most religious countries over on the right are the ones that least accept evolution. The least religious countries on the left are the ones that most accept evolution. There's the United States. So we're next to last, right above Turkey on the right. Now, relevant to your question, what would happen if I put sub-Saharan Africa and the Middle East on here? All those points would be way down there in the lower right. Because those areas, sorry? I don't know Latin America. We don't have data on that. At any rate, so the data would be even stronger if you use sub-Saharan Africa and the Middle East, where there's high religiosity and very low acceptance of evolution.
Where would Canada be?
Canada? It's up there somewhere. Oh, Canada's really good. I've given this talk. Yeah, I've given this talk in Canada, and the Canadians are big acceptors of evolution, and of course they're less religious than Americans too. Now, this doesn't implicate necessarily religion. First of all, it shows there's an inelastic demand curve for Darwin. That is, you have to give up 35% of your belief in God before you can increase a 10% acceptance of Darwin. So, you know, an economist will look at this and say, you know, belief in God is malleable, but it doesn't connect much with belief in Darwin. Second of all, this doesn't tell you which factor is responsible. It could be that those countries in which people are taught evolution more tend to reject God more. Or it could be that those countries that are most religious tend to be resistant to evolution. And that, in fact, is the case. You get your God before you get Darwin. You know, you get your God from your parents when you're very young. That makes you immunized against evolution. In fact, there's lots of evidence for this. I'll show this in the States. These are the 50 American states. I wish you could read it. Arrayed from greatest acceptance to evolution at the top to least acceptance at the bottom. And the blue lines are accepting of evolution, the red ones are rejecting it. So we have the good states up here, the blue states. This is just a coincidence, of course. And the other states at the bottom. Now, does this correlate with religiosity of these states? And it's hard to get data on the religiosity of American states. I could find the 10 most religious states and the 10 least religious states in this country online, and here's where they are. Those are the most religious states in America: Alabama, West Virginia, Mississippi, West Virginia, Louisiana. The southern states are the most religious. Those are the ones that also are the ones that reject evolution. Here's the 10 least religious states in America: Massachusetts, Vermont, Connecticut, Rhode Island, New Hampshire. These points are non-overlapping. Already, this is a highly statistically significant pattern. So just as among countries, also among states, religiosity is a correlate with rejecting evolution. That should be prima facie evidence. It certainly is to anybody who's taught evolution their whole lives. The resistance to this true scientific theory comes only from religion. And you can tell that from looking at creationist organizations in the United States. Every single one of them is religious. Here's a list of some of the famous ones, and they all have religious overtones. Answers in Genesis, CSE Ministries, Creation Ministries, etc. It's religious. Also, Intelligent Design, which masquerades as a non-religious organization, but it's really called creationism in a cheap tuxedo. That's why I put the bow tie there. But that also, the Discovery Institute, which is a prime promulgator of intelligent design theory, is also a religiously based organization. So the fact is, you can have religion without creationism in this country. There's lots of religions that are explicitly down with evolution, like Unitarian Universalism. Even the Catholic Church professes to be on the side of evolution, although it's really not. We can talk about that later. But you cannot have creationism without religion. There is no reason to reject evolution unless you have some alternative divine-based theory of origins. So what I'm going to do for the rest of this talk, except for a few minutes in, is talk about this book, which was on sale downstairs. All 4 copies that they saw fit to order have been sold out. But you pissed me off because there's a gazillion copies of Henry Kissinger's book. That's what they think of evolution versus... Never mind. Don't get... Yes? All right. Anyway, I've asked them they'll order the book for you and send it to you for free if you want. And if you want to send it to me in Chicago, I'll be glad to autograph it for you. But the rest of this talk comes from my book, Why Evolution Was True, which was written some years ago. But it is the first book that was designed to give the average layperson in America a view of why scientists accept evolution. So before I do that, I have to tell you what we mean by true. It's called the theory of evolution. What do we mean by theory? And finally, I'll tell you what the theory of evolution is. The rest of the time, I'll tell you what the evidence for evolution is. Okay, so a theory is simply a set of propositions that's well supported by the evidence. It's not a wild speculation or a guess. That we call a hypothesis in evolutionary biology or in all of science. It's a theory. A hypothesis is the Cubs are going to win the pennant this year. Okay, a theory is that the Cubs may win the pennant sometime in the next 50 years. Okay, but anyway, evolution is a theory well supported by the evidence in the same sense as the theory of atoms, that the smallest elements of matter that retain its chemical properties are atoms, and the germ theory of disease, that infectious diseases are caused by microbes. Those are called theories too, but they're true theories, and in that sense, evolution is a true theory. Now, what do we mean by a true theory? And this is Stephen Gould's definition of what a truth is in science. It's an assertion for which there's so much evidence that it would be perverse to deny it. We don't have absolute truth in science. We have truths that are provisional, that are the best explanations we have. There's no bell that goes off when it goes ding, 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 ding. Okay, we finally found this to be true. We can only keep improving our knowledge. But some things are so unlikely to be changed that we will take them as we would bet our house on it. And I would bet every penny I had that evolution is true. So that's what we would mean by something that's true in science. And so these other theories, the theory of atoms, disease-causing microbes, and evolution, are also true theories in the same sense. So when you hear somebody dismiss evolution by saying, it's only a theory, like Ronald Reagan did in 1980, you have to realize that that bespeaks a profound ignorance on their part of what a theory is, as well as a sort of a sneaky motivation to impugn something that's one of the best supported theories in science, best supported facts and theories in science. So evolution is a theory, just like the germ theory of disease, but it is also a true theory. It is a fact. Okay, so now I'll tell you what the theory of evolution is, because this is what we need to find evidence for the rest of this lecture. And it's 5 things, actually. It's more than one thing. So this is what I conceive of as the theory of evolution. First of all, that evolution happens. That's the basic part. And by evolution, I mean genetic change in a population over time. The population, over generations and generations, turns over its genetic composition, and that causes perceptible change in the population. So evolution happens. Second of all, evolution is gradual. That is, a population does not change overnight into something profoundly different. It didn't. It could have, but it didn't. This is evidence as well. It takes hundreds of thousands of generations, for example, to transform a dinosaur into a bird, which is what happened. So it's not instantaneous, and an individual doesn't evolve. The population evolves as its genetic composition changes from one generation to the next. There's splitting or speciation, that is, an ancestral species can split into 2 other ones, B and C. And that's what created from a single origin, and we know life started only once, at least life that gave rise to existing organisms started only once. It splits, and then it can split again and again and again until we get this ramifying tree of life. It's so ramifying that we can't even represent it by a tree anymore. It's sort of depicted by a wheel. And this is only a very small fraction of all the species on life that originated with that Ur species in the middle, about probably 4 to 3.9 billion years ago. That's part 3. Part 4 is the reverse. It's basically the same as part 3. That is, if you have a splitting that results in descendants, that you can trace any 2 living species back to a common ancestor sometime in the past. So all life is connected through common ancestry. The more recent common ancestors are the ones that you say are most closely related to. I'll show you that in a minute. So this is just the reverse side of part 3. If you have a splitting of a tree into twigs, then you can take any pair of twigs and trace them back to a common node or branch on that tree. Common ancestry of all life. This is part 4 of the theory of evolution. And there's an example. This is the primate family tree, and we can see the 2 closest relatives to us. The sister species, the chimpanzee, about 6-7 million years ago. The gorilla about 10, the orangutan about 13, and so on and so on and so on. Recent ancestry or close relationship means that your common ancestor lived more recently than your more distant related species. And finally, and this is what Darwin saw as his most novel contribution to the theory of evolution, that the features of organisms that make them look so well adapted to their environment, the spines of the cactus, the hump of the camel, the wings of the woodpecker, the bill of the woodpecker, those things are molded by this process called natural selection. And you could read more about that in Richard Dawkins' book. So those are the 5 parts of the theory of evolution, and in order to find evidence for them, you have to find evidence for all of them. You can't, because they stand independently. You could have evolution, but it might be instantaneous rather than gradual. Or you could have evolution, but you might not have splitting or common ancestry. Or you could have evolution, but it might not be propelled by natural selection. So in order to support this theory, you have to find evidence for every bit of it. And that's what I'm going to tell you now. So evolution makes predictions, first of all, which are obeyed by the theory of evolution, but not by creationism. If evolution were true, then we should be able to see that the first organisms on Earth, because they formed out of chemicals floating around somewhere in hydrothermal vents, perhaps, should be very simple organisms. Replicators, very simple cells. And then as time passed and evolution occurred, organisms should get more complex. And this is exactly what we see. This is the geological column right here, starting when the Earth was formed at about 4.6 billion years ago. We don't have any rocks that old on Earth, but we're pretty sure that's how old it is. We see the first life at about 3.8 billion years ago, and it's very simple. These are bacteria, cyanobacteria, photosynthetic bacteria, once called blue-green algae, and they form these layers called stromatolites. So the very first trace of life that we can recognize as whole organisms on this planet are these things, sheets of cyanobacteria, and we can actually see the individual cells. And then as you see, as life proceeds, as we go up for the next 3.8 billion years, things get more and more complicated. We get cells, we get trees, we get organisms, and we get humans. That's not to imply that evolution is a one-way march to humans, because we still have cyanobacteria with us today, and we still have them forming these little sheets. You can see them in certain isolated places like Shark's Bay in Australia. So the simple things that were first there, their descendants are still with us as simple things, but then more complex things form. Now, creationism does not predict this. If you read Genesis 1 and 2, everything came into being at the same time. Some of it was wiped out by the flood. The attempts of creationists to justify how the fossil record gives evidence for the flood are so risible that I'm not even going to mention them here. But this fossil record is evidence for evolution. Another prediction is, because evolution is gradual and it occurs in populations, that you should be able to see it in the fossil record. You should be able to dig up a fossil record and see gradual change and splitting. Because remember, those are 2 independent parts of the theory of evolution. And here's a prime example of that. This is the evolution of horses, which took place largely in North America, even though they went extinct and were reintroduced by the Spanish. Horse evolution, it took about 55 million years to go from that tiny little thing at the bottom, which was about this big, about the size of a collie, and it had 4 toes. And then as evolution proceeded, the organism lost its toes to 3 toes to 2 toes and then 1 toe. I won't give the middle figure here. I always do that to creationists. One toe. So a horse is walking on its middle toe, although occasionally it shows traces of its previous toes. The teeth got bigger, and the body got bigger, so you can see that. And so we can see this lineage right here. This is evidence for evolution, because we can find a lineage of horses on the right that changes itself over time gradually, over 55 million years, to go from a small thing to a big thing with large teeth and big bodies. But we also see splitting. So you can see there's lots of lineages of horses that split off and went extinct. And we know this because we have such a good fossil record of horses in Western North America. And we also have many species of horses that were several of them, different zebras, Przewalski's horse, the donkey, the horse. These things all live today. So those are the results of the same kind of splitting. So here we see both gradualism, evolution, and splitting. We can also see natural selection, sort of, because this happened at a time when Western North America was losing its forests and becoming grassland. And when you lose your forests and you're a leaf-eating or herbivorous mammal, then you have to run on grassland. It's much more efficient to run on hooves than it is to have feet like this, which impede you. Also, if you're eating grass rather than leaves, you want to have big, high-crowned teeth, because grass has high proportion of silicon in it. If you tried to eat grass, your teeth would wear down to nubbins almost instantly. Whereas eating leaves, you don't need that kind of special teeth. So this evolution of the horse goes along very nicely with what we knew was happening in the environment at the time horses were evolving. So you could say this gives evidence to almost all 5 parts of evolution. But of course, I'm going to give you more. Here's a vestigial horse. Its developmental program for suppressing those extra toes has gone awry. So you can see there's some extra toes forming. They still persist in the form of splint bones on the side of the horse. That's the splints. I think Alexander the Great's horse Bucephalus is supposed to have had extra toes, but maybe a classical scholar could verify that. Here's another example of splitting and gradual change. This is the hominin lineage, the lineage of everything on our side of the family tree since we diverged from the ancestors of chimpanzees. And these skulls are all arrayed in temporal order. They're not arrayed in an order to look progressive. They're arrayed in the order of the time that was determined by various dating methods. This is a chimpanzee, and a modern Homo sapiens in the lower right. And you can see the gradual change over time. The brow ridges recede. The skull, which is originally small, 400 to 500 cc's, gets big, about 1,200 to 1,300 cc's. The teeth get smaller because we're eating meat now and other things. And you show this picture to creationists and they just get flummoxed. And they'll say, well, this one's clearly an ape, but this one's clearly human. So, there's some creation event here. But they can't really draw a line of demarcation where humans really began. So this kind of evidence is really deeply disturbing to most creationists, and they try to wave it away. But it is exactly what the theory of evolution predicts. It also shows that we show branching and gradualism. We don't know exactly what the family tree of humans are. We find out more every day, as you probably know from reading the newspaper. But this is the best guess we can make now, that there is a single lineage that goes from Australopithecus to Homo sapiens here. That's a questionable one. I put a question mark by it, but whoops, sorry. We think that's the lineage, but we also see these other species on the right, the robust hominins that went extinct. And there may have been as many as 5 separate species of Homo or other species in the hominins that lived together in the same place, which is something very interesting to contemplate. We know 2 of them, which are Neanderthals actually Denisovans, Neanderthals and Homo sapiens, which lived in the same place at the same time. And I don't even think they're separate species because we know they copulated with each other. How many of you have Neanderthal genes in your genome? You would, all of you, if you had your DNA sequence. It's because there was some sneaky copulation between these, what are called by many people species, but I call them subspecies. But the process of splitting, of gradualism, and of evolution are instantiated in this picture. Okay, more predictions evolution makes. If creatures had common ancestry, then we should be able to find evidence of that common ancestry in the fossil record. And it's usually put like this. So for example, Thomas Henry Huxley, who was Darwin's great defender, Darwin's bulldog, postulated that because birds appeared in the fossil record after reptiles, but they had a number of similarities. Birds and reptiles lay eggs, they have physiological similarities, that birds evolved from an early reptile. Okay, that was a theory. We didn't have any fossils, really. At the time Darwin wrote, there was hardly any fossil record. So how do we, what do? We need to look for the missing link between birds and reptiles. That's an impossible task, because the missing link is the one species of early reptile, all of whose descendants on one side gave rise to modern reptiles, and whose descendants on the other side gave rise to birds. That's a single species that we need to find in the fossil record. We wouldn't even know it if we found it, because it would just look like a normal reptile. So how can we find these missing links? Well, there's another way to do it. What you do is you start at the top of the fossil record with modern birds, and you dig down and down and down and down to about 200 million years ago, and you should find birds becoming increasingly reptile-like. In other words, you should find transitional forms. And we do. Okay, we find that the earlier the bird you get, the more reptilian it looks. Now, creationists dismiss this. This is what they see as an intermediate form between a bird and a reptile. They call it the croc-a-duck, and it's a croc of something, believe me, but it's not. This is not an adaptive organism, but this is the way creationists make evolutionists look stupid. They say, look at this thing. I mean, how can anybody believe that this is an organism that could evolve or could be adaptive? I mean, it's just dumb. And the whole audience pounds their Bibles and laughs and stuff. But, but this isn't the way it happened. This is the way it happened. This is a transitional form between a reptile and a bird called I always get this wrong, Deinosaurus millenii, which has features of both reptiles and birds. First of all, the reptilian features, which very much resemble the theropod dinosaurs, those small, fast-running dinosaurs that lived you can see them in Jurassic Park chasing people around the kitchen. It has, for example, teeth. No living bird has teeth. This fossil has teeth. It has separate hand bones, as you can see. If you look at your chicken, they don't have separate fingers. They're all fused together. And finally, it has a long, bony tail. No modern bird has a long, bony tail. But, so many of these skeletons that were found were mistakenly thought to be dinosaur skeletons until in China, they found impressions of feathers where the red arrows point to. And so now, all the time, we're finding feathered dinosaurs more and more and more. What better example of a transitional form between a bird and a reptile can you have than something that has an essentially reptilian skeleton but is covered with feathers? It's exactly what you predict, and it's exactly where you could predict. It appears in the fossil record at 125 million years ago. That's after the first reptiles appeared, which is about 270 million years ago, but before we see the first modern birds at about 70 to 80 million years ago. So not only is it right in the way it looks as a transitional form, it's right in the way where it appears exactly. This is what it looked like, probably. We're being able to reconstruct the colors of feathers now. It couldn't fly. Feathers did not evolve to help birds to fly. They evolved for other reasons, probably thermoregulatory or sexual display. But it doesn't matter. What we have here is evidence of intermediate forms. Here's another one, Basilosaurus. This is an early whale. Actually, it's a well-evolved whale. Whales evolved in 40 million years from land animals that were small, deer-like animals. And one of the later ones is Basilosaurus. And you can see it has this 55-foot skeleton. It has nice paddles in front. This is, in all effects, a whale. But if you look towards the rear of it, you see these little things sticking out the side. Okay, what are those things? We'll zoom in on them. They look like that. They're tiny little legs, just this long. Now, they're of no conceivable use to a completely marine organism, but they have every feature of a terrestrial tetrapod leg. It has the femur, the tibia, the fibula. There's our leg. You can see every bone is homologous. How can a creationist explain this? Except by accepting the evolutionary fact that whales evolved from land animals, which we already knew because there were mammals, and there were mammals on the land before there were mammals in the sea. That's the organism that is thought to be the ancestral whale. It's called Indohyus. It's like the muntjac, the Southeast Asian deer that can swim underwater for great distances. Okay, here's some, I'm going to have to skip some of this, I can see. Evolution also makes retrodictions. This is a word I invented myself. But it's a very important thing in Darwin's book because Darwin showed that his theory of evolution made sense of a lot of disparate and puzzling biological facts that biologists had either passed over or had wondered about for many years. And so the fact that evolution can explain things that were previously inexplicable is itself evidence for the truth of evolution. Here's one of them. It comes from embryology. It's the spotted dolphin. If you look at the development of a spotted dolphin, and the spotted dolphin looks like that up in the right, it has 4 limbs, its paddles, but it doesn't have any rear legs. Its tail doesn't have any bones in it, so it doesn't have any rear legs, yet it evolved from a land mammal. If you look at the development of the spotted dolphin at 24 days, you'll see that it has limb buds, fore and hind limb buds. How do we know that these are limb buds? Because we can look at another species that has 4 legs. That's the human embryo at 30 days. And sure enough, it has the same forelimb and hind limb buds. So we see this development, and Darwin pointed this out in his book. The dolphin begins by developing 4 limbs. We go on as embryos to develop these limbs in our arms and our legs. But for the spotted dolphin, at 48 days, these hind limb buds begin to go away. So it starts growing legs, but then it aborts them. Now, why does it do that? And you can show that the genes that are activated in forming these legs are the very same genes that are activated in forming our legs. HAN2, sonic hedgehog, these are the names of the genes. How can you explain this disappearance of an organ which is starting to be formed and then goes away? You can't do it as a creationist unless you think, well, God is some kind of trickster that makes us think that dolphins were developing legs, but he just did it as a giant joke. But no religious person wants to think of their deity as somebody who's fooled the whole world of scientists by manipulating embryology. So they basically keep their mouths shut about this. And sometimes dolphins the development will go awry, and they will develop hind legs like that. And if you dissect those things, you'll find that it has the same bones in them that our legs do. Same thing with us. We show signs of our ancestry. Every single one of us at the age of about 6 months was covered with a thick coat of hair called the lanugo. And a premature baby that is born at 6 months will be covered with hair, like a young chimpanzee. The parents will be aghast, and the pediatrician will say, don't worry about it, it's going to fall off, as it does. Now, why at one point in development, when we're in utero, are we covered with a thick coat of hair, and then that coat of hair is shed before we're born? Well, a creationist could say, well, it could keep us warm in there. And you know that's not going to fly because you're floating around in 98.6 degree fluid. Hair is not going to keep you warm. It's just going to be an impediment. The only explanation is that we evolved from a hair-like animal. We're the naked ape. We've lost our hair. And we still show the beginnings of the development of hair. But then we lose it. That's the way evolution works. Sometimes it starts forming a feature, but if that feature is not adaptive, we don't know why we lost our hair, but it's no longer useful for us, then it just aborts the development. Okay, vestigial genes. There are, in the human genome, we know this now because we can sequence the human genome, remnants of genes that were active in our ancestors but are dead now. When evolution gets rid of a feature, it doesn't snip the genes out of the DNA. There's no way for it to do that. It simply silences them by putting mutations in them that make them no longer useful. So here's a vestigial gene and a vestigial character. Here's a human embryo at 4 weeks. There it is right there. And the placenta looks like a fish, more evidence for evolution. We see this big balloon sticking out of its navel. What is that thing? Does anybody have an idea? There's nothing in it. Well, if you were a chicken, what would you say it was? It's the yolk sac. And in fact, we form a vestigial yolk sac when we're about 4 weeks old. From this, scientists predicted that, well, if we had a vestigial yolk sac, maybe in our DNA somewhere, we would find genes for yolk proteins. They might not be expressed anymore, but they might be there. And sure enough, about 20 years ago, when scientists sequenced the genome, they found that we had 3 genes for making egg yolks, but they're all dead. They're all inactivated by mutations. Now, you tell me how a creationist can explain that. Why do we have all these dead genes that were useful in our relatives and our ancestors, unless you think that the divine creator is a trickster? No, the evidence is that we don't need egg yolk anymore because we're nourished by the placenta, okay? And we have many, many dead genes. Our DNA is a graveyard of genes that reflect our ancestry but are no longer expressed. We have the whole pathway for making vitamin C, but we don't need to make vitamin C because we get it in our diet. The last gene in this pathway is inactivated. The last enzyme is inactivated by mutation. So this is why we need vitamin C, why sailors will get scurvy unless they have their lime ration. Many of the genes that are involved in smelling, the olfactory receptor genes, are dead, several hundred of them. Why are they there? Because we are related to carnivores and insectivores, for which smelling was far more important. We're an auditory and an olfactory an auditory and a visual species, not an olfactory one. We don't need to smell as well as a dog does. And so we have all these genes which can detect odors, but they are no longer functional. Okay. How can you explain that unless evolution is true? I'm not going to even go into biogeography. It's a very long story. Just let me say that the distribution of species on oceanic islands like Hawaii and the Galapagos, which rose from the sea without ever having life on them, show peculiarities which can only be explained by evolution. They lack endemic mammals, amphibians, and reptiles, but they have lots of insects, birds, and plants. Exactly the kind of thing you would expect if these islands were populated by things that got there by floating or by being pooped out by birds or by flying. Okay, Darwin pointed that out in 2 chapters of The Origin, and I won't go into that. That's evidence that creationists have never addressed, by the way. Okay, so I won't go into that. And we should be able to find natural selection operating in nature if evolution was true. This is the last point of evolution that we need to substantiate. It's hard to find evidence for natural selection because it's so slow. It operates very, very slowly, causing changes on the orders of thousands or millions of years, and yet we can find it operating in the human lifetime. We have over 300 cases now documented in this book by John Endler. The most famous case, which was the evolution in the beak shape of the medium Galapagos groundfinch, Geospiza fortis, due to a drought. Only the big birds with the big beaks were able to eat the seeds. After the drought, the little birds died. You could find them on the ground. Beak size increased by 10%, and in 1 generation. That's a remarkably fast rate of evolution, and we know it's natural selection, and we know exactly how it worked. And we have lots and lots of cases. Evolution creates bad design. This is the worst design I can think of, but this is exactly what you can predict from evolution, because evolution by natural selection takes what you have and improves it gradually step by step. It's not like a designer sitting down at the drawing board de novo and saying, I'm going to create something that's optimal. Evolution doesn't predict optimality. It predicts the best we can get, and the best we can get is this prostate gland in males, which consists of a collapsible tube which goes through an organ prone to swelling. The prostate gland produces the seminal fluid in male ejaculate. And as you know from watching television, that it can swell, and that's why you see all the ads for Flomax and stuff like that if you watch the evening news, because there's all these guys on the golf course that suddenly have to pee, and you know, that's because the prostate gland is swelling and cutting off the urethra. This is a bad design. An organ prone to swelling around a collapsible tube. Robin Williams described this as running a sewage pipe through a playground in one of his more forgettable movies. Okay, so I can say QED now. I've proved all the 5 parts of evolution. From the fossil record, we see change, splitting, and transitional forms, like in the horses and our own fossil record. We see vestigial organs and genes, which cannot be explained except by evolution, like the egg yolk proteins or the vestigial legs of Basilosaurus. We see quirks of development, like the development of our lanugo that goes away, or the hind limbs of the spotted dolphin. We see bad design, the prostate gland, our bad back. We see biogeography, which I couldn't get to, and we have examples of natural selection in real time. Note that these are drawn from many fields of biology: paleontology, embryology, morphology, biogeography, and fieldwork. We have many different lines of evidence, and they're all conciliant in saying why evolution is true. Okay, so that's what we mean by truth. That it would be perverse to reject all the evidence I just gave you. Nevertheless, there are observations that could show evolution could be wrong. It doesn't mean that everything we find we can somehow slide into a preconceived theory of evolution. It just so happens that what we found buttresses evolution. I'm not going to go over this list, but I made a list of a dozen things that could falsify evolution. If one of them is fossils in the wrong place, like a human fossil 300 billion years ago, or an adaptation in one species of animal that could only be good for another species, like nipples on a lion that can only be used to suckle a warthog. Evolution tells us that a species cannot evolve a feature that is only good for another species. And sure enough, we don't find any single example of this in nature. Okay, so I'm winding up now. I just have 1 minute left, and we'll have some time for questions. Given all these facts, why does America reject evolution so much? Why are only 19% of Americans accepting of evolution of the way I described it? It's because of religion, because our country is so deeply religious, much more than you know. If you take a poll, you'll see that 63% of Americans believe in the existence of angels. Not metaphorical angels, not Thomas Aquinas, sophisticated theology angels, real angels with wings. They might be invisible, but they think they're there. Contrast that with a percentage of people that believe in Darwin. This is a national shame. And finally, the last fact, this was a poll taken about 12 years ago by the Time Roper organization. They asked people, if science found a fact that contradicted your faith, the tenets of your faith, your religious faith, what would you do? Would you accept the scientific fact and reject what your religion tells you? Or would you accept what your religion tells you and reject the scientific fact? What do you think? What proportion of Americans do you think they would reject the science in favor of their religious belief? Yeah, we got a cynical crowd here. It's not quite that high. I mean, I've heard 100 sometimes, but, well, it's more than that. It's 64%. So 2 in 3 Americans are going to reject the fact if it goes against their faith. This also explains Donald Trump, but I won't get into that. But it does explain the rejection of evolution. And so this is really what we need to do. And the contrast between religious belief and belief in science or evolution in general is another book, which I can talk about some other time, Faith versus Fact. But anyway, thanks for coming, and we have a few minutes for questions.
So, Jerry, one of the brilliant and surprising things about the way you delivered this case is that you hardly touched on DNA sequence, and the fact that you can measure evolutionary distance by comparing DNA sequences, which is such a powerful piece of evidence for many of us who don't know bones and don't do dating.
I did that on purpose because if you say, well, the DNA of a chimp is more similar to a human than that of, say, a gorilla, then a creationist could say, well, that's because God made us, similar using our DNA as the plan. Mm-hmm. But the real evidence from DNA, which is evidence for evolution, is that we have all these dead genes.
Yeah, dead genes, but then the ubiquity of the code and
the ubiquity of the code, plus the fact that even the parts of DNA that don't code for anything also show the same evolutionary relationship.
There is a whole other lecture that can be built on DNA analysis.
Correct.
Questions from the audience? Yeah. We have microphones, and shout, but better to use the microphone.
So what's your feeling on our prospects in the future for man to be able to influence evolution of our species?
Oh, we can do it easily. I mean, the main thing is we drive them all extinct. But I mean, extinction is the ultimate non-evolution, but we can, there's ample genetic variation that we can make a species do almost anything at once. And the evolution of the Chihuahua from, for example, the wolf is the greatest explanation of that. But humans aren't really doing that on purpose to most of the world's species. They are imposing huge changes on the environment, the most notable of which is...
What about Homo sapiens?
You mean what's going to happen to us? Well, we've already ruined ourselves with medical care. I mean, now I have bad teeth, I have bad eyes. Most of us would be dead by now if we didn't have antibiotics. But how many of you want to say, let's natural selection operate? We're not going to give anybody antibiotics. So by inventing things, and medical care in particular, we have stopped a lot of, not all of it, but we've stopped a lot of the evolution that occurs. And I don't know if you're asking that. You might be asking, where are we going now? And that's the question I always get in popular lectures. Are we getting smarter? Are we getting handsomer? And all I can do is tell you what the data are, which are long-term horizontal and longitudinal studies about what characters are connected with reproductive success in our species, because those are the ones that will evolve, and they're boring. Women are getting menopause later. They're coming into reproductive condition earlier. Heart disease, at least in Western countries, is going down, and the Dutch are getting taller.
I'm surprised you don't get asked questions about gene editing to try to make the species.
Sorry?
I'm surprised you're not getting questions about gene editing, at least from high school students.
Oh, yeah, I know. I haven't done that. I mean, yeah, we will, because of the CRISPR program, we'll be able to change humans at will, but whether the ethics will prevent us from doing that, I mean, we could presumably, we don't know if this is true, make kids with blue eyes and high IQs and tall kids some centuries down the line. I don't know if that's going to fly, but in principle, we have the ability to engineer humans and even get rid of some of these bad traits like bad teeth and bad eyes that we have, but I don't think that's anywhere in our future.
Sarah Bacon.
Thank you. This is a question for both of you. Is there a drawback, speaking to gene editing, to, say, getting rid of what was referred to earlier by Alta, the Huntington's gene, or other rare disease genes? Are there any drawbacks? That's the only instance where I can see benefit to gene editing is nixing the genes that cause terrible genetic diseases, which is at least 80%, if not much more.
That's right.
Well, you don't need to do gene editing to prevent transmission of the gene, because we can do DNA testing of embryos, and so it's not a necessary step to take to get that gene, the bad gene, out of the gene pool. Secondly, we don't know enough yet about how editing is done to prevent CRISPR doing something unwanted at the same time that it's doing the thing you want. In the back, lady in the white coat.
I'm curious why this debate is so dualistic. In other words, why can't there be a point of integration where there's a polarity and the two views are held in common or with empathy for each other? For example, there are other areas where clerics and religious types will seek scientific support or consultation, and then the doctor will refer to God and the supernatural in the healing process. So why can't there be that with this topic?
Well, there is actually. I mean, there are religious people who are friendly to science, and there are scientists who are religious. Francis Collins, who I believe is Harold's successor at the NIH, is an evangelical Christian, but that doesn't mean. I mean, the answer to the question was expressed by Sean Carroll in his talk. We know what's the physics of everyday life, and evolution is part of everyday life, and there's simply no evidence at all for the supernatural. So when people say, let's call for comity, or let's call for a dialogue between science and religion, a respectful dialogue, my answer is that we don't need a dialogue, we need a monologue. We need scientists to tell religious people what's true, because religious people don't have a handle on any truth about the universe. So, you know, because they all say different things about the nature of the universe and how it was created and things like that.
And maybe the word religious is a bit of an overstatement, because there are a lot of religions that are completely compatible with evolution.
Yeah, there are very few, though, I have to say. The Catholic Church says it's compatible with the Pope himself has pronounced that evolution is okay.
But how about Buddhism and Hinduism and Taoism?
Well, remember, the Dalai Lama himself believes in karma and reincarnation.
Yeah, well, they have those stories, but you know, I don't think it's I think there are plenty of Hindus and Muslims and
well, there's a lot of Hindus that are anti-evolutionary. So there are very few religions.
It doesn't correlate as well as it does with the evangelical Christian.
Yeah, but the fact is, I mean, if you read my book, Face versus Fact, I'll just say it straight out. There is no evidence for any kind of truth to any religion anywhere, and so why should I take it seriously? Why should I even engage in dialogue with those people, except to say, well, you're a human being, I respect your opinion, but I think you're wrong, and here's the truth about the universe, which is evolution.
There is another religion, that's called jazz, and that's going to happen downstairs in a couple of minutes. And as a son with a jazz musician, I think we're going to say thank you to Jerry. And
thank you.